One is on operations of functions, right? So we're going to be dealing with functions again. In this chapter, in this section in particular, we're going to be talking about what we can do with these functions. So if you have two separate functions, right? You can add the functions, you can subtract the functions, you can multiply and divide the functions. And you know how to do this and for the most part, it's the notation that we have to get used to. All right, so first off, if you want to add two functions, right? So suppose I have f of x and I have g of x, right? And suppose I want to add these two functions. Well, I can either write it like that, f of x plus g of x, or there is another notation which is a little bit more efficient, and I can sort of eliminate writing the x twice. So I could just write it as f plus g of x, right? So they mean the exact same thing, it's just in more concise notation, right? All right, so, and all you have to do if you have f plus g of x is you take one function, you take another function, you add them. How do we add functions? You just combine like terms, just like you've been doing since your Algebra 1 days. All right? Well, what about the subtraction? The notation for that is f minus g of x. And again, you take your f, you take your g, and you subtract them. Now, what's the difference in this case, right? Suppose this is f of x. It's just 2x. And now g of x is negative x plus 5. Right? Now, subtraction is always tricky, right? So if you want to do f of x, which is 2x, minus g of x, which is this, the trick is you've got to put parentheses around it when you're subtracting. Okay? Because it's a whole quantity that's being subtracted. Do you absolutely need the parentheses when you're adding the two functions? No. Okay? All right, multiplying is the same. So look, you take, it's f times g of x. So you take f of x, which is 2x. Then you take g of x, which is this one, and you multiply them. Again, you must have your parentheses. Must have them, because what are you going to do with the 2x now? What's the word? You're going to distribute. Excellent. Now, in the case when you're dividing f over g of x, you just take your f, you do a fraction bar, divided by your g. Now, most of the time, it's just going to be that. Sometimes it's possible to simplify further, and if you can simplify further, you must simplify further because we're now in Algebra 2. Yes? Okay, so that's just to cover ourselves, right? If x were equal to 5 in the denominator, what would that denominator equal to? So if I had a 5 in the denominator for x, so if it was negative 5 plus 5, what would the denominator equal to? 0. Is it possible to get a denominator of 0? Can you divide something by 0? You cannot. That's like saying you have 2 pieces of chocolate and you want to divide it between 2 of your friends, right? Or you have 2 pieces of chocolate and you want to divide it between your 0 friends. That's not cool. Okay? All right. So let's do some examples here. The first case, and I'm missing another set of parentheses here. The first case is f plus g of x. So I'm going to take f and I'm going to take g, and what am I going to do with them? I'm going to add them. Yes. All right. Let's color code this because why not, right? This is f and this is g. All right. So what this says is take f. Is that f? And now take g. That x, it just says that your functions have a variable of x. It's just the notation. Because it's f of x. It's g of x. Okay?
But why wouldn't you just like eliminate that because it doesn't like why is it still there?
Because we can't, if we just do, okay, so here, what's my function? It's f of x, right? F of x is equal to 3x squared plus 7x, right? Okay. Now, what does this notation f of x mean? Well, the f is the name of the function. So when I see f of x, f parentheses x, in my mind, I'm thinking, okay, there's going to be a function coming up. The name of the function is f. And what's the variable used in that function? X. All right? So if I had h of t, what would the name of the function be? H. And what variable would be used in the function? T. So that's just that's a labeling scheme.
Right.
Okay.
I understand what like it is, but why is it there? You don't use it for it.
It has to be there because it's part of the name. Okay. It's sort of like your middle name. It's there. Sometimes you use it, and most of the time you really don't care that it's there. Right? Okay. All right. So I have my red function f. I have my blue function g. What am I going to do to these? I'm going to add them. Now, do I need parentheses when I'm adding them? No. Is it wrong if you put parentheses? No, but you don't need them. Okay, so let's go ahead and add them. I'm going to combine like terms. 3x squared and 2x squared will give us 5x squared. What else can I combine? The 7x and the minus x is plus 6x. What else? Minus 1. And there you have it, folks. There you have it. Okay? All right, the next one says f minus g. So I'm going to take my f again, and I'm going to take my g. What am I going to do with these two? Subtract them. Can I just do that and be done with it? No, I need parentheses. Okay? You've got to have your parentheses. So now, the negative gets distributed inside. So I have 3x squared plus 7x minus 2x squared minus times negative x is positive x, positive 1. All right? So when I combine like terms, what do I have? X squared plus 8x plus 1. There it is. Okay? All right. Let's do a multiplying. Now we have a fresh new set of functions. This is f, and g is x minus 4. Now I'm going to multiply them, right? So I have 3x squared minus 2x plus 1. If I'm multiplying two functions like this, what do I put around each one? Parentheses. Okay, what do I do with this?
You do each term to x and each
Right. You can either do each term, you could either distribute the blue into the green into the blue, but what can I do it the other way as well? Here's what I mean. Can I distribute the x to here?
Yeah.
Let's do that. You will totally get the same answer. Okay, so now 3x squared times x will be 3x cubed. Now, minus 2x times x will be minus 2x squared. 1 times x is plus x. Now I'm going to distribute the negative 4 to this, that, and that. So 3x squared times 4, negative 12x squared, you're right. Oops. So negative 12x squared, positive 8x, negative 4, and now let's combine terms. So 3x cubed minus 14x squared plus 7x minus 4. 9x minus 4. All right, and it has to be in standard form, decreasing order of exponents. Okay, f over g of x, I have 3x squared minus 2x plus 1 divided by x minus 4. Now, how do you know if you're able to reduce this? Okay, you have to see if you can factor any of them, all right? What's more is, once you factor, are you going to be able to cancel anything out? That's when you go ahead and start factoring. If by factoring you're not going to be able to cancel anything out, you don't even have to factor, okay? In this, yeah, no. So for example, suppose you factored. Suppose you had a completely different set of functions, right? And you factored, and suppose on the bottom you had x plus 1, and you factor the top and you get x plus 2 and x plus 1, right? Can you now cancel out the 2x plus 1s? You could. That's when it's beneficial to factor. If not, don't even bother with it. So in this case, I'm just going to leave it like this. Okay? It's fine for now. Okay, now for the big stuff. Okay, so here's the big stuff. Composition of functions. What does it mean? What does that word composition mean? Or a composite, what does that mean?
A part of.
Right? Something that's made of some other stuff, right? All right. Well, a composition of functions is a function that's made up of one or two different functions. So we're going to get two functions, put one inside the other, and compose a brand new function. Okay? All right. How do you do this? To find a composite function, you begin with the first function. What do we mean by first? Sometimes I call it the first function. Sometimes I call it the outer function. So you start with the first function or the outer function, and you replace x with the second function. Oh my gosh, what does it all mean? Well, I'll tell you what it means. All right, so here I'm given an f of x and a g of x, all right? And for the first case, I'm told to find f of g of x. This is how we read it, f of g of x. Okay, there is another way I can write this. I can write this like this, f of g of x. Okay, right. I can write it like this, f of g of x. Okay?
So, to make a composite function, you just multiply f times g.
No, we're not multiplying. So okay, so this is another way of writing it, right? Now, which one is the outer function here? F or g? The one on the outside.
Okay.
That's f, right?
Oh, is that the only way to determine?
This is the one that's outside is the outer function. And do you see how g looks like it's nested inside of f? So this is the outer function. Okay? Now, here's how I do this. Once I've identified that f is the outer function, I copy down f of x, just like this. Okay? Now, compare these two. The one in the green and the one in the black. One says f of x. The other one says f of g of x. So, what is x being replaced with? G of x. So now, look at what I'm going to do. It's f of g of x. So wherever I see an x, right, what am I going to substitute it with? G of x. Okay, so Here we go. I start with my function. Okay, so far it's just 3. I'm good. Oh my God, I see an x there. What am I going to replace x with? 2x minus 1. Then you, hang on. Then you continue with your function. Minus, what am I going to replace x with? 2x minus 1 plus 4. Okay, now what? 1. All right, so let's see. There's a 3 here. Okay, how do we square 2x minus 1 the quick way? You square the first term. Uh-oh. That's never happened before. You square the first term, and that gives you 4x squared. You square the last term, and that gives you 1. What goes in the middle? Negative 4x. 2 times negative 1 times 2x. Okay, so let's continue. We're going to distribute the negative. Minus 2x plus 1 plus 4. Let's continue further. 3 times 4x squared is 12x squared. Minus 12x plus 4. Minus 2x plus 5. So this is 12x squared minus 14x plus 9. And this is f of g of x. 8. And there's a 4 and then a 5. Oh, here there's a 3. Sorry. Okay, so that's the answer there. All right. They are similar, yeah. All right, now we're going to do g of f of x. What's the outside function now? G. So now what I'm going to do is it's g of f of x. So what am I going to put inside of what? F inside of g, right? So what's g of x? G of x is 2x minus 1. G of f of x is 2 times what? Three x squared minus x plus 4, and then what? Minus 1. So let's distribute 6x squared minus 2x plus 8 minus 1. So this is 6x squared minus 2x plus 7. This is g of f of x. Okay? All right. Down here in example 4, we have 2 more. So what I'm going to do now is I'm going to have you do these 2. All right, you've got an f of x and a g of x. Find f of g of x and then g of f of x. And stop, don't move on to example 5, right? So do A and B, don't move on to example 5. And I will stop this and give everybody a chance. Let's see. 4 to 5 minutes should do it. So we've got our example 4, A and B, we're set. Now, look at example 5. You have f of x. You have a g of x, right? Now you're being asked to find f of g of minus 1. F of g of minus 1. So it's no longer f of g of x anymore. Now, there are 2 ways to do this. You can do what we were doing and find f of g of x and then plug in minus 1. Or you could do it another way. So I want f of g of minus 1, right? What you could do is start from the inside. This time start from the inside. What's g of minus 1? That's g of x right there. And what's g of minus 1? It's 2 times 1 plus 6. Does everybody agree with that? Okay. Second semester, we have to do it a little bit more independently, right? Does everybody agree that that's going to equal 8?
No, you have to put the square.
Speak now or forever hold your peace. Right, so initially I was looking for f of g of minus 1, right? Like that. So it's f of, and what's g of minus 1? 8. Now can I find f of 8? That's going to be 3 times 8 plus 2. How much is that? 26. So that is your answer. Okay? So the next one says to find g of f of 3. All right? Now, what's the inside one? F of 3. So let's just find f of 3 first. Where is my f of x? What's f of x? 3x plus 2. So what's f of 3? 11. Does everybody agree with that? Yes, f of 3 is 11. All right, now it was that I was looking for g of f of 3, but what's f of 3? 11. So now I have a brand new problem to find g of 11. Well, what's g of 11? That's 2 times 11 squared minus 6 times 11. What's 11 squared without using the calculator? Or 121 minus 66. On Wednesdays, it's 121. So this is 242 minus 66. And what's 242 minus 66 on Wednesdays? Okay, so going back to f of 3, f of 3 is going to be 3 times 3 plus 2, right? And that's, okay. So now, final answer, g of f of 3 is how much? 176, okay? All right. Now, this homework will be due the next time you have class.